Triangle ABC has vertices A, 1, 0, B, 3, 0, and C, 3, negative 1. Draw triangle ABC on the axes below, labelling all the vertices. So we have 1, 0, 3, 0, and 3, negative 1. So this is our triangle, and that's A, B, and C. Triangle ABC is transformed by matrix T1, which is 0, 1, 1, 0, to form triangle A-B-C'. Determine the coordinates of A-B-C' and draw a labelled triangle A-B-C' on the axes above. Okay, so one way of doing this is to take the matrix 0, 1, 1, 0 and then form a matrix of the coordinates. So for A, that's at 1, 0. For B, that's at 3, 0. And for C, that's at 3, negative 1. And then if we multiply, so we do 0, 1 times 1, 0, that's going to give me 0. If I do 1, 0 times 1, 0, that gives me 1. So that's going to be where A dashed is. Then we do the top row again times the 3, 0, that gives us 0. And the bottom row times 3, 0 gives me 3. That's B dashed. And then 0, 1 times 3, negative 1 gives me negative 1. And 1, 0 times 3, negative 1 gives 3. That's the position of C dashed. So we have 0, 1, 0, 3, and negative 1, 3. So that's this triangle just here. A dashed, B dashed, C dashed. Describe the geometric transformation that matrix T1 represents. Well, T1 is 0, 1, 1, 0. Now, if we think about the matrix 1, 0, 0, 1, that means that 1, 0 has become 0, 1. So in other words, this point here has gone to here. 0, 1 goes to 1, 0. So in actual fact, these points are just interchanging. That's a reflection in the line y equals x. So that's the geometric transformation represented by T1. Triangle A-B-C' is rotated 180 degrees about the origin to form A-B-C'. Determine the transformation matrix T2 that represents the transformation from triangle A-B-C' to A-B-C' and draw label triangle A-B-C' on the same axis as triangle ABC. So I think I can draw the rotation first. So we're talking about this triangle at the top here being rotated 180 degrees. And that means that A double dash would be here, B double dash would be here, and C double dash would be here. And so what we have is this triangle just here. Now, if we think about the matrix, so for a 180 degree rotation, the point 1, 0 would go over here to negative 1, 0. That gives us the left-hand column of our matrix. We think about 0, 1, 180 degrees would take it to 0, negative 1. That's the right column of our matrix. Determine the single matrix T3 that will transform A'-B'-C' to triangle ABC and determine the geometric transformation that T3 represents. Well, there's a couple of different ways of doing this. So we did this one first, and then we did this one. So one way of doing it is to multiply those matrices together, and the -1, 0, 0, -1 would have to be on the left. The other matrix was 0, 1, 1, 0. And that's because the point xy would come in from this side. So we do that transformation first. So this would take ABC to A double dashed, B double dashed, C double dashed. So let's do the multiplication. So if we do the top times the left, -1 times 0, 0 times 1 is 0. And then the top times the right is going to give me -1. Bottom times the left gives me -1. Bottom times the right gives me 0. So that's that matrix. And what we want is the inverse of this one to map back the other way. So the determinant there is 0 times 0, take away -1 times -1. And so that is -1. So the matrix we want is -1. Swap the leading diagonal, take negatives of the other diagonal, and that gives me 0, -1, -1, 0. So this one here is what's known as a self-inverse. Now let's think about that matrix. If we look at the left column, it's telling me that 1, 0, let's write it as a column vector, 1, 0 has gone to 0, -1. It also tells me that 0, 1 goes to -1, 0. That looks like a reflection in y equals -x. So it's a reflection in y equals -x.